Good morning, HOD Professor A.K. Chaturvedi sir, my seminar guide Mr. K.S. Bhati sir, seminar coordinator Dr. S.S. Godara sir, faculty members, examiners and my friends. I am Abhinav Vyas, pursuing my B.Tech in Aeronautical Engineering from University Departments, Rajasthan Technical University, Kota. My seminar topic is Microwave Propulsion System. This is going to be a list of contents. The first thing will be the introduction of microwave propulsion system. Second will be the background. Third will be the technical overview. Fourth will be applications. Fifth will be comparison to the other propulsion systems, challenges and limitations, future outlook and conclusion. Moving forward, when we talk about a microwave propulsion system is a type of advanced propulsion technology that uses electromagnetic radiation in the form of microwaves to produce a thrust for the spacecraft or the other vehicles. The microwaves are generated by a device called magnetron and are directed towards a reaction mass, often a propellant gas, which is heated and expelled out of the spacecraft, creating a thrust in opposite direction. One of the key advantages of microwave propulsion is that it can provide higher specific impulse, a measure of thrust efficiency, than chemical rockets which rely on combustion to generate the thrust. Microwave propulsion can also potentially use a wider range of propellants including inert gases such as xenon or argon, which can be more efficient than the traditional rocket fuels. So this was the introduction of microwave propulsion system. Moving forward, when we have the background, the history of microwave propulsion system dates back to 1960s when the concept of electromagnetic waves for propulsion was proposed. However, it was not until the 1980s the researchers began to seriously investigate the potential of microwave propulsion. One of the early pioneers of this field, Dr. James Woodward, who in 1990 proposed a concept of resonant microwave thruster that used a resonant cavity to generate thrust by bouncing microwaves back and forth within the cavity. He demonstrated that this amount of thrust, published several papers on the subject. In the following years, the researchers continued to investigate various forms of microwave propulsion. In 2001, NASA began funding research into microwave thrusters called as the cannon drive, which used a different approach to generating the thrust by using the dielectric material to convert the microwave energy into the mechanical force. In 2014, a team of Chinese researchers announced that they had successfully tested a microwave thruster in vacuum chamber, which producing a small but measurable amount of thrust. This was followed by similar announcement from the team of NASA's Johnson Space Center, who reported in 2018 that they had tested the microwave thruster for the EM drive in a vacuum chamber and observed a small amount of thrust. Moving forward, when we talk about the type of microwave propulsion systems, that what are the microwave propulsion systems that we use? The first one is the resonant cavity thruster, or you can say the RCT. These thrusters are a resonant cavity to generate the thrust by bouncing the microwave back and forth within the cavity. This concept was proposed by Dr. James Woodward in 1990 and has been studied by the other researchers since then. Dielectric thrusters is the second way how the microwave propulsion system can work. These thrusters use a dielectric material to convert the microwave energy into the mechanical force by producing thrust. The cannon drive, developed by the Guido Feta in 2001, is an example of this thruster. The third is electromagnetic thrusters. These thrusters use electromagnetic waves to generate the thrust by including the current in the conducting surface. An example of this type of thruster is EM drive, developed by Roger Schwager in 2001. The fourth is plasma thrusters. These thrusters use the microwave to ionize gas and create plasma, which is then accelerated to produce the thrust. Examples of the plasma thrusters include the variable specific impulse magnet to plasma rocket VSIMR and the helical double layer thrusters HDLT. The fifth type of microwave propulsion system is magneto-hydrodynamic thrusters. These thrusters use microwaves to heat a fluid and create a magnetic field, which is then used to accelerate the fluid and produce thrust. This type of thrusters is still in the experimental stage and has not yet been demonstrated to produce useful levels of thrust. Moving forward, when we talk about the technical overview of microwave propulsion systems, also known as the electromagnetic propulsion systems, are a type of advanced propulsion technology that uses microwave to generate thrust. These systems are still in experimental stage, but they hold the potential to revolutionize the space travel by providing more efficient and powerful propulsion for the spacecraft. The basic principle of the microwave propulsion is the use of microwave to generate plasma, which is expelled from the spacecraft as an exhaust. This is achieved by using microwave antenna or array, which is used to generate a high intensity electromagnetic field that ionizes a gas such as hydrogen or helium. The ionized gas is accelerated using a magnetic field and ejected out from the spacecraft through a nozzle providing thrust. Working of microwave propulsion systems. When we move forward towards it, there are several stages how the microwave propulsion system works. The first thing is the generation of plasma. A gas, typically hydrogen or helium, is introduced in a chamber where it is ionized by the microwave radiation. The ionization process creates the plasma, which consists of positively charged ions and negatively charged electrons. The second stage is magnetic field acceleration. The plasma is then accelerated using a magnetic field. This is achieved by creating a magnetic nozzle that focuses and compresses the plasma, causing the accelerate in a specific direction. The magnetic field is generated by a set of coils or a superconducting magnet. The third stage is the exhaust. The accelerated plasma is then expelled out of the spacecraft through a nozzle. This generates the thrust that propels the spacecraft forward. Next thing when we move is the applications of the microwave propulsion systems. In future, as we know that the microwave propulsion system is going to be the best alternatives for the current propulsion systems that we use. It can be used for the interplanetary missions, asteroid and comet missions, debris removal, CubeSat and small satellites, station keeping and orbit control. When we talk about the interplanetary missions, microwave propulsion systems can enable a faster and more efficient interplanetary missions. For example, a microwave propulsion system could be used to propel the spacecraft to the Mars and the other planet in the shorter time than the traditional chemical propulsion systems. This would reduce the time travel and increase the amount of time available for the scientists for the observations and experiments. Asteroids and comet missions. Microwave propulsion system can also be used in exploring the asteroids, comets. These missions often require precise control of the spacecraft's position and orientation, which can be achieved more easily with the help of microwave propulsion system than the other propulsion systems. In addition, microwave propulsion system can help reduce the risk of collision with the asteroids and comets. Moving forward, for the debris removal, microwave propulsion system could also be used to remove the debris from the Earth's orbit. These systems could generate a magnetic field to capture and remove the debris from the orbit, reducing the risk of collisions with the other spacecraft. As we know that debris is one of the greatest problems that we are facing right now. Fourth is the CubeSat or the small satellites. Microwave propulsion systems are well suited for the small spacecraft such as CubeSats and the small satellites. These systems can provide high specific impulse and thrust to power ratios in compact, lightweight packaging makes them small spacecraft missions, station keeping and orbiting. Microwave propulsion systems can also be used in station keeping and orbit control of the large spacecraft, such as the International Space Stations or the other manned stations. These stations can provide precise and control and adjustment of the spacecraft's orbit, enabling it to maintain its position and orientation in the space. Moving forward, when we talk about the advantages of microwave propulsion system, it has high efficiency, lightweight, lower cost and scalability. So these are all are the factors which makes it different from the other propulsion systems that we use. Moving forward, when we compare the microwave propulsion system to the other propulsion systems, here it goes in such a manner. With comparison to the chemical propulsion systems such as a liquid or a solid rocket are currently the most used propulsion systems for the space missions and require a large amount of propellant, making them too unsuitable for the long duration. And in comparison, microwave propulsion system offers a much higher specific impulse and can operate for much longer period of time. Electric propulsion systems. When it is compared to the electric propulsion systems such as the ion thrusters or the Hall effect thrusters use electric fields to accelerate ion or plasma to produce thrust. These systems offer higher specific impulse and more efficient use of propellant than the chemical propulsion systems, but they still require a significant amount of power and have limited thrust to weight ratios. In comparison to the microwave propulsion system, offer even higher specific impulse and higher thrust to power ratios, making them suitable for the deep space missions. Moving forward, when we talk about the nuclear propulsion systems such as the nuclear thermal rocket or thermal electric propulsion use nuclear reactions to produce the thrust, and these systems offer high specific impulse and are capable of producing large amount of thrust for a long period of time. However, these have significant technical safety associated with them. In comparison, microwave propulsion system offer high specific impulse and high thrust to power ratios but do not require the use of nuclear materials. Moving forward, when we talk about the challenges and limitations of microwave propulsion system. Microwave propulsion system is relatively new and experimental in technology. There are several challenges and limitations that must be addressed before we consider it for the spaceflight missions. The challenges are, first thing, that low thrust is produced. Microwave propulsion system generates very low levels of thrust, which makes it difficult for accelerating a spacecraft quickly, and such deep exploration missions are not worth it right now. Moving forward, for the power requirements, microwave generators use the system require a significant amount of power which can be used from the spacecraft with the help of outfitted large solar arrays or other means of generating power. Next comes the reliability factor. The technology behind the microwave propulsion is still being developed and refined, and there are concerns about its reliability and longevity over a long duration mission. Controversy. There are various controversies with the microwave propulsion system too, with some of the scientists challenging that the theoretical basis for the technology and disputing experimental results. This controversy makes it difficult to secure funding and support for further research and development. Safety. One of the key factors. There are also concerns about the potential health effect of the high-powered microwave used in these systems on both the crew as well as on the environment. Moving forward, when we talk about the future outlook, microwave propulsion systems have the potential to revolutionize the space exploration and enable the mission that are currently impossible with existing propulsion technologies. Here are some of the future outlooks for the microwave propulsion system: advanced technology, interstellar missions, in-space propulsion, commercial applications, and collaboration and partnerships. When we talk about the advancements in technology, researches and developments in the microwave propulsion systems are ongoing, and the advantages in the technology could lead to further improvements in the efficiency, power, and reliability. This could make the microwave propulsion system even more attractive for the use in a wide range of missions. Interstellar missions. Microwave propulsion systems have the potential to enable the interstellar missions by providing high speed and reducing the need of the large amount of propellant. Researches into the microwave propulsion system could pave the way for future interstellar missions in space propulsion. Microwave propulsion systems could also be used in space propulsion, allowing the space to travel within our solar system and explore new destinations. This could include the missions to Moon, Mars, and the other celestial bodies. Commercial application, the potential for the high speed travel and reduced propellant consumption could make the microwave propulsion system attractive for commercial applications such as satellite servicing and space tourism. Next comes the collaboration and partnerships. The development of the microwave propulsion systems will require the collaboration and partnership between the government agencies, research institutions, private companies. These collaborations could lead to further advancements in technology and successful implementation of microwave propulsion system for the future mission. In summary, the future outlook of microwave propulsion system is promising, and its continued research and development could lead to even more exciting applications and missions forward. Now I would like to conclude. And moving upon the conclusion, in conclusion, microwave propulsion is an experimental technology that holds a promise as a potential propulsion system for the space missions. While the concept behind microwave propulsion system has been met with the specimen and controversy, experimental studies, and net forward thrust using the microwaves such as the resonant cavity thrusters or EM drive. So thank you for your attention, and I hope you find this